Good day! So sa lesson na to, we'll take a quick look at integrals that will yield inverse trigonometric functions. So ano yung itsura ng integrand na pag in-integrate natin siya, ang result natin ay inverse trig, inverse sine, inverse tangent, inverse secant. So we'll use trigonometric substitution to prove the following theorems. So ito na actually yung integrands na ang form nila magbibigay sa atin ng inverse trigonometric functions. So we'll prove each of these three equations ng paisa-isa, starting with yung magbibigay sa atin ng inverse sine. So, first theorem, the integral of the expression 1 over square root of a squared minus u squared du. A dito is a constant ha. This should be equal to inverse sine of u over a. So yung proof natin, gagamit tayo ng trigonometric substitution. Ayan, so let's use trig sub where u is equal to a sine theta and necessarily du is equal to a cosine theta d theta. So let's perform the substitution. That means our given expression will be equal to the integral of 1 over a squared minus u squared, but u is equal to a sine theta. So yung denominator natin ay square root of a squared minus a squared sine squared theta. Then yung du natin, papalitan natin ng a cosine theta d theta. Looking at the denominator, we should be able to factor out yung a para masulat natin yung denominator as a times the square root of 1 minus sine squared theta. Then yung a cosine theta dito, we could move it up dito sa numerator para makita natin na yung a tsaka yung a dito, they will cancel each other out. I guess you could see rin na ang square root of 1 minus sine squared ay square root ng cosine squared. But sige, tuloy lang natin. So numerator natin as is, yung denominator natin magiging cosine theta na lang, square root ng cosine squared d theta. Of course, yung dalawang cosine magka-cancel to give us that this integral is equal to the integral of d theta after trig sub. But what is the integral of d theta? That's just theta plus c. So ibabalik lang natin si theta na in terms of u. Kasi u yung variable natin eh. And let's recall na yung substitution natin, u is equal to a sine theta, making theta equal to arc sine u over a. So, our integral, yung 1 over square root of a squared minus u squared du, this is equal to arc sine of u over a plus our constant c. And we have proved this theorem. So, ginamit ko lang yung box. I think you should be familiar na ito yung parang pang-end ng proof, Parang QED, but mas maiksi. Let's take a look at the second form. Yung 1 over u squared plus a squared du. This is equal to 1 over a. 1 over a times the arctangent of u over a plus our constant of integration. So, here's the proof. Siyempre, gagamit pa rin tayo ng trig sub. So, we'll let u be equal to a tangent theta, making du equal to a secant squared theta d theta. Then, applying the substitution, we'll get na yung given natin na integral of 1 over u squared plus a squared, this will be equal to 1 over yung u squared natin magiging a squared tangent squared theta, well, plus a squared pa rin. Then, yung du natin, papalitan natin siya ng a secant squared theta d theta. And we could factor out yung a sa baba, a squared sa baba actually, and cancel out yung a and yung a squared. So may matitira na lang na 1 over a. And take note, ano ba si tangent squared plus 1? Diba? That is secant squared then. Secant squared then. Yung 1 over a, nilabas na natin sa integral. So this will give us the result that is equal to 1 over a times the integral of d theta na lang. So again, what is theta? Theta is equal to arctangent of u over a. So yung result natin na 1 over a theta, substitute lang natin si theta. This will give us that our integral is equal to 1 over a arctangent of u over a plus c. And that ends the proof for this second theorem. And for the third theorem, we want to prove that this form 1 over u times square root of u squared minus a squared, ang integral niya equal to 1 over a arc secant of u over a plus our constant of integration. For our proof, gagamit na naman tayo ng trig sub. So we let u be equal to a secant theta and du be equal to a secant theta tangent theta d theta. Let's perform the substitutions. We'll get that our given is equal to, denominator muna, so u magiging a secant theta square root of u squared, so a squared secant squared theta minus a squared. Tas yung numerator natin will be a secant theta tangent theta na lang, then times d theta. Notice we could cancel out na agad, no? Yung a tsaka yung secant theta. And you could also take out yung a sa denominator na out of the square root, and we'll have tangent theta over square root of secant squared theta minus 1. You should be able to see where we are going. Ano ba ang secant squared minus 1? Tapos kukunin mo pa yung square root. So labas natin yung 1 over a. And since alam natin na ang secant squared minus 1 ay tangent squared, tapos square root mo pa, so yung tangent tsaka yun magka-cancel out. This will just be 1 over a times the integral of d theta, which is theta plus c. And getting an expression for theta, since u is equal to a secant theta, then theta must be equal to arc secant of u over a. Replacing yung theta dun sa result natin, we'll find that this form will give us 1 over a times the arc secant of u over a plus our constant of integration. And that ends our proof. For our next videos, we'll take a look at some examples na gagamitin natin to. And for now, salamat sa pakikinig.